Precalculus Assignment 1, Solving Equations and Inequalities. This assignment covers solving these 10 types of first and second degree equations and inequalities. These are all topics that you should have covered in Math 104, 105, or Algebra 1 and Algebra 2 in high school. So if it seems like this is reviewed for you, it should be. But if it all seems like it's pretty new to you, then you might consider that you need to either take Math 105 again, or really going to have to study this so that this becomes something that you can do very easily, because we need to be able to do these things in order to do the pre-calculus concepts that will come later. So let's just go down through these 10. And while we're doing that, think about, does this seem like something I've done before, or is it brand new? Equations in one variable. There we have just an x in the equation. It's all to the first degree, so we should be able to solve that. Rational equations contains fractions where the x is in the denominator. Rational means fractions. Equations with more than one variable. We actually have 4 variables there, and we're asked to solve it for b. This is more like we would handle a formula. Inequalities. So we have an inequality sign instead of an equal sign here. Equations with absolute value. So now we have an absolute value inside of an equation. Inequalities with absolute values. So we have the absolute values now and an inequality. Quadratic equations. This is where we have a second degree equation where the exponent is 2. Quadratic inequalities. Now we have a quadratic equation, but instead of having an equal, we have an less than or equal to sign. Equations with one radical. We can see that this has one radical in it. And then equations with 2 radicals. And so we need to deal with that a little differently. So once again, think about as we're going through these 10 and how to solve them. Does this seem like new material to you, or is this review? It should definitely be review. 1. Linear equations in one variable. In order to solve an equation in general, we need to follow these steps. 1. Clear all parentheses and fractions. 2. Collect like terms. 3. Put all the variables on one side and the constant terms on the other. So let us start. So we see we have some parentheses, so what do we do first? Clear the parentheses by using the distributive property. So we're going to go 2 times x is 2x, and 2 times 1 is 2. So we get 5x minus 3 equals 2x plus 2 plus 4. So now what are we going to do? Collect like terms. And where are the like terms? The only ones that are like on any one side is the 2 and the 4. So we need to add the 2 and the 4 together. We get 5x minus 3 equals 2x plus 6. Now what do we do next? Put all the x's on the left and all the numbers on the right. Now it doesn't really matter which side you put them on, but you got to get all the x's on one side and all the numbers or constant terms on the other. So we're going to do this by subtracting 2x and adding 3 from both sides. This will keep our equation balanced. And we get 3x equals 9. So now what do we do next? Divide both sides by 3. So dividing both sides by 3, the 3 goes into 3x, and it gives us an x. 3 goes into 9 and gives us a 3. So we have x equals 3. What does x equals 3 mean? It means that when you put the 3 into the equation, it will make the left side equal the right side. So now we'd like to check it. The way to check it is to rewrite the equation, parentheses wherever you find an x. This is the best way. So follow this procedure and you'll be more successful. So now we have parentheses where the x's are. So next, we're going to put the 3 in the parentheses and then evaluate both sides. And they both turn out to be 12, so that means it did check out. 3 is our solution. 2. Rational equations. Now we have fractions. And if you look at the steps in solving an equation, you get rid of the parentheses and fractions in step 1. So how do you get rid of the fractions? You need to find something that x, 2, and 6x will all divide into. So we need to clear the fractions by multiplying both sides by a common denominator. It doesn't need to be the least common denominator, but it's best if you can find the least common denominator. So what is that common denominator in this particular problem? That's right, it's 6x. So we're going to multiply by this 6x. And we're going to reduce as we multiply. Let's just go through it right now before we actually do the reducing. In that first one, it would be 6x over 1 times 3 over 6x. So you can cancel the x's ahead, but I wouldn't put lines through them. Or you could multiply across and get 18x over x. But then the x's are going to cancel, so we're going to end up with 18. Then we repeat the whole process with the 6x over 1 times the 1 over 2. Now you can cancel the 2 with the 6 and give you 3x, so we'd end up with 3x. Now you think about the right-hand side. If you multiply the 6x over 1 times the 5 over 6x, you could cancel the 6x's ahead of time, or you can go 6x times 5 is 30x, and then 30x divided by 6x is just 5. So then we're going to multiply the 6x over 1 times the 1, and that'll give us 6x. So we get 18 plus 3x equals 5 plus 6x. Now what are we going to do? Put all the x's on the right and all the numbers on the left. So we're going to subtract the 3x from both sides and subtract the 5. That's right, we get 13 equals 3x. And what are we going to do next? That's right, divide both sides by 3 so we can get a single x on the right hand side. So x equals 13 thirds. Now we're going to want to check this too. So our check, we put parentheses wherever you see an x in the original equation. Then in the parentheses we put our 13 thirds. We try not to panic because there's fractions. And simplify. We get 13/26 equals 31/26. So it did check out. 3 equations with more than one variable. AB minus C equals D. Solve for B. To solve for B, we need to get B by itself on one side. So if we look at our equation, we see that there's an A over there and there's a C over there. But if they were numbers, we'd get rid of the C first, so we're going to do that with the letters also. So we're going to add C to both sides. We're going to get AB equals D plus C. Now we have to look and say, well, we got to get rid of the A, so we'll just have a B there. It's being multiplied, so we're going to divide both sides by A. We have AB over A equals D plus C over A. And dividing it out, we get B equals D plus C over A. So since we have the B by itself, we are done. Note, in the answer above, we cannot let A be 0 since we cannot divide by 0. Also, in the original, if A equals 0, then B is eliminated, and there is no solution for B. This fact that we cannot divide by 0 causes us a lot of problems in algebra, and it's something we always have to consider because it can pop up in any type of algebraic expression or equation.